This is our IoT project called Aquarium Monitoring System. It's based on sensors and actuators, thanks to which it's possible monitoring also a huge number of aquaria. The heart of our distributed system is the Raspberry Pi 2, in which there is the whole set of scripts written in Python, like web services, user interface, and classes. It is also a data collector. In fact, it runs a broker called Mosquito, a gateway that sends stored data through the internet. The system is also composed by a sensing node and an actuation node, which are these two Arduinos. In particular, in this video I will briefly try to explain you how this system works step by step. Sensing node samples temperature, level and pH values and sends them either in an LCD monitor 16x2 close to the aquarium user and to the broker running in the Raspberry. Messages containing values are here processed by the process control software. Results are sent to the ThinkSpeak platform, which allows us to draw temporal graphs that will be available in the final user interface called Freeboard. These three LEDs represent the actuators. The blue one represents light, the yellow one the pump, and the red one the heater. ThinkSpeak has its own refresh time of 15 seconds, and for this reason graphs are not instantaneously updated with respect to the LCD monitor. Going to the Freeboard platform, here we can see the user interface, which is very simple. Level graph is an on-off-like graph. If level is beyond a certain threshold, which is chosen in the Arduino sketch, water is enough, and graph will be set on 1. If level is under the threshold, it's considered as low, and graph will be set on 0. pH goes from 1 to 14. A pH sensor is very expensive, and for this reason we have simulated it into an Arduino sketch that generates random values belonging to this range. Beside these graphs, we have inserted also warning messages to the user. If a sensor samples something wrong, in the sense that value is out of the optimal range for the specific aquarium, a warning message will notice the user that something is not okay, and actuation nodes will start working, in our system represented simply by LEDs. In the final system, actuators will be composed by heater for low temperature values and a pump for low water level. In this case, our aquarium shows a temperature of 21.4 degrees. This means that it's needed a heater action. In fact, our Arduino actuator will show a red LED turned on, which is the heater, which is turned on, and the warning message is set to warning temperature is down. At the same time, we can also throw away some water in this way. Level will be set as low, and Arduino actuators will show a yellow LED turned on, and Freeboard will show a warning message related to water level. At the end, there is a button which provides the actuation of a little servo engine in order to feed fishes. Each time the button is pressed, a GET request is performed and the engine is activated. Parameters of engine are set in the Arduino sketch. When the button is pressed, a warning message will notice the user that feed is already performed.